Precalculus, lesson 1.3, graphs of functions. What you should learn in this lesson: we're going to find a domain and range of functions. We're going to do the vertical line test to tell if something's a function or not. We're going to determine the inroads of increasing, decreasing, constant on a function. We'll find the relative min and max of a function. We'll graph some piecewise functions. Then we'll talk about how to identify even and odd functions. So the graph of functions is just a collection of ordered pairs. So here's your graph, x, y, right? You have a point, x and y. Sometimes people call it x and f of x. F of x is just y. They're the same thing. So f of x, same thing as just y. And it's an ordered pair, right? So all the x values is just how far do you want to go away from the y-axis. So if I give you 3, you're going to go 3 from the y-axis. And then all the y values, or f of x values, is how far you want to go from the x-axis. So I give you 4, you go 4 up from the axis. And that's a graph. It's a collection of all those points. So let's do our first example. So here's a graph. Here's f of x. Here's a graph of the function shown to find the domain. We'll do this one by one. So I want to find the domain. Now remember, domain are the x values. So we're going to go from left to right. So if we look at this graph here, our domain, like I said, right there, right? It's the x value. So how far left does your graph go? This is the furthest left our graph goes. And then how far right does your graph go? It goes from here all the way, if you follow the graph, to here, to 4. So our domain can go from -1 to 4. Now here's the thing. On a domain, if you see a closed circle, that's going to be a bracket. And if you see an open circle, that's going to be a parenthesis. It's called interval notation. So over here, our -1's on a closed circle. We do a bracket, -1. And we're going to go all the way until we get to 4. 4 is on an open circle, so we'll do a little parenthesis. Like that. So something to that effect. So that's our domain, from -1 to 4. You can also write it, so that's interval notation. You can also write it in set notation, which would be x is between -1 and 4. So either of these is fine. So that's interval notation. And this is set notation. Right, so this is letting you know, hey, our domain goes from -1 to 4. This is letting you know your x values, the domain, goes from -1 to 4. Either way is fine. I don't care which one you turn in. B, find the function values f of -1, f of 2. So let's do B real quick. B wants f of -1 and f of 2. So what this is asking is saying, hey, your x value is -1, what's the y value? If we substitute in -1, what's our y value? So all we're going to do here for this one is go, where does x equal -1? If you look at your graph, -1's right here, right? Here's my x. And then where's -1 at? Right there. Now where's the graph at? So follow where the graph at? Down there. Right? All the way down here. So -5 is my answer. So that's all this means. Our x value, remember it's f of x, right? That's what this stuff is. So our x value is -1. What's the y value? So on this one, f of 2, x is 2. So go to 2 in your x. Then where does it hit the graph at? Up here at 4. So we start at 2, and then we're where does it hit the graph? It hits it at 4. So that's how you figure out what f of -1 is, or f of 2 is on a graph. You just figure out where that value is on the x, follow it on the graph. Okay, last one, find the range. Change my color. So we want the range of f(x). So the range is the y values. So we're going to go low to high. Right, when we do domain, we go left to right. So if you're on the left, it goes to the right. When we do the range, we go low to high, and we're doing the y values. Let me change the color. That's not very so. Okay. So lowest I see my graph. Let's erase some of this. So you can see a clear graph here. The lowest our graph goes is down here. This is the lowest point. Same rules apply, right? Our lowest, see how it's a closed circle? I'm going to do a bracket. So -5. Notice I did the y values, right? What's the lowest? That's the y values. So -5 is my lowest. What's the highest? It's not this guy. It's this guy. That's the highest my graph goes. Right, so low to high, lowest is -5, highest is 4. Right, we're looking at the y's. So -5 to 4. That's my range. Or if you want to do set notation, you could do -y5, y to 4. Right, so same idea, just set notation. So that's how you do domain and range. That's how you evaluate figures. Now we know how to find domain and range given a graph. How about if I just give you an equation? So the domain is the easy part. Domain, we talked about in the previous lesson. It's about what numbers you can plug in. So really you just gotta think about, okay, what can you not do? So like in a square root like we have here, remember you cannot have negative numbers under the radical. So these things, your domain is going to be x is greater than or equal to 0. It's like start off. Right, those are like the numbers you can't have. You can't have, if you're talking about square root, you can't have any negative numbers. So my domain for this one's going to be x minus 4 is greater than or equal to 0. And we just got to solve. Again, we set this up because it is a square root. We do it this way, and then we just go plus 4, x is greater than or equal to 4. And that's your domain. All numbers are greater than or equal to 4. That's in set notation, and most of the time we just leave it like that. If you want to do interval notation, this is the same thing. Probably the best way to write it if you want interval notation. Just draw it. So there's 4, close circle that way. So outstanding is saying, oh, we're going from 4 to infinity. So the general rule of thumb, if you're doing a graph, you probably want interval notation. It's a little easier to read. If you're solving domain like this, you just leave it in set notation. That's the general rule of thumb. How do you do range? Now, range is tougher than domain is. So if you're doing range just by looking at it, you have to think, okay, what numbers do I get out? If I do this, what numbers do I get out? You can't get a negative square root because square roots don't go negative. So your range is going to be 0 to infinity. Or y is going to equal to 0. Or you could say 0 to infinity. Right? But that's a lot tougher. By the way, infinity is always a parenthesis. It's never a bracket. You can never reach infinity, so it's always a parenthesis. That's a lot tougher because you can't just like do a math problem. You got to look at it holistically and kind of go, okay, what numbers do I get out of this? When I plug numbers in, what do I get out? So the easiest way for me to do range, and we're not there yet, so you're going to see this more later on, is I would just graph it. So if I was doing this problem, I was like, oh, what's the range? I would just take a quick graph of this. I'll show you right now. We'll do this more in a later lesson. If you know the graph, if you know your graphs, you're like, okay, what's my range? My range is from 0 to infinity. That's my range. So like that. So for me, when I do domain and range, if I have to do it with an equation, honestly, my range, I just graph it. Unless I can think about it logically. Domain is for me, it's a lot more straightforward. You just have to solve the problem if there is a problem. So we'll do more of that in the coming days. How do you tell if something's a function or not? So what we have is called the vertical line test. That lets you know if something's a function or not. So vertical line test is just, you have your graph, draw vertical lines. If you hit more than once, you have this guy here, right? He hits it twice. This guy failed the vertical line test. So this is not a function. So you draw straight lines. If at any point you hit it more than once, that means you have 2 x's for the same y. That's not a function. And then the opposite here, right? No matter where I draw a straight line in this guy, vertical line, hence vertical line test, I'm only ever going to hit it once. So this passes. So this is a function. So that's a vertical line test. Next up, let's talk about increasing, decreasing functions. Increasing, decreasing functions, hopefully pretty straightforward. Keep in mind we read from left to right. That's the key to this. So it's kind of like a roller coaster. This is like the fun bit, right? Where you're sliding down. Whee! So, kind of like that. So it's decreasing. And then this is constantly going straight. And then this is like the uphill climb. So that's increasing. So as long as you read from left to right, it's pretty straightforward. The other key thing about it, it's the x values. I always think about like, when are you increasing? When are you decreasing? So if we're looking at this one, right? When is it decreasing? It's not 4 to 1. That's the y values. It's when x values. So -2 to 0 is decreasing. Constants from 0 to 2, increasing from 2 to 4. X values. That's the big deal. this. So, do a quick example. Determine the open intervals on which the function is increasing, decreasing, or constant. So let's put increasing here, decreasing, and constant. So this first one here, so if you look at it, it's increasing. If it's going up, right, it's increased from here to here. It kind of stops for a split second, then it increases again. So I would put something like negative infinity to 0. Negative infinity is this guy. Look, when in time it keeps on going, little arrow there, that is negative infinity. And then it looks like it stops at 0. Then it goes on again forever. So infinity. Decreasing, nowhere. It's not decreasing anywhere. So you could put like empty set or leave it blank. Constant, just at 0. So here's a little, you can put a 0 there, but technically if you don't put a 0, you're supposed to put like little curly brackets. So you put like close in parentheses when it's like from here to there, right? Like it's an interval. When it's only one number, you're supposed to put curly brackets. Would I mark you down? No, but if you're going to be higher math, it starts getting more important. This one here, right? We're going to do increasing, decreasing, constant. So let's see, increasing, right? Where it's going up. So I would say from here to here, and from here to here. Those are my increasing. Right, so that would go from negative infinity all the way to -1. Remember the x values, not the y values, not how high. When does it stop? It stops at -1. So negative infinity to -1. Union, I didn't explain this last time. Anytime you have more than one answer as the interval, you generally put a u in between. You can union them up. And then we're going to start again at 1, and we're going to go all the way to infinity. Like that. Decreasing is the middle here. So again, x value is -1 and 1. And then constant, there's no constant. If you notice, I didn't put any brackets. You don't put, when you put increasing and decreasing, you generally don't put brackets on these things, because it's like at -1, you're both increasing and decreasing, right? It's like in between. So it's just always parentheses. Okay, so that's increasing and decreasing. Similar idea for min-max values. Min-max values are like, oh, actually I should go back. Relative min-max values. So what that means is it's the highest thing in the area. So if you look at here, right, this is a relative max. This is like higher, that's a maximum. But in this little area here, that little hill, that's the max. And the same thing down here. These are the lowest in that area. So relative min, relative min. So that's what the relative is about. It's like the smallest in that area. If I was going to do this here, this actually doesn't have a relative max or min. If you see it goes up, stops for a second, goes back up again. Notice there's no like hill or valley. There's none of that. This doesn't have that. So it actually has none. This one has a relative max and a relative min. Right here. Relative max. So we generally say relative max is 2 and it happens at -1. Sorry, x equals -1. So the relative max is the y value 2 and it happens at -1. Over here, right, that's my relative min. See how that's the lowest in the area? So my relative min is -2 and it happens at x equals 1. Or you could just write f of 1. That works. Same thing here. If you always want to write, you could say f of -1 if you wanted to. Either way is fine. Keep in mind for this one, these are straight up relative maxes. This is not the highest point in the graph, because this graph goes on forever. Same thing here. That's not the lowest point in the graph. It goes on forever. They're relative in the little area that's max or min. Okay, next up, let's sketch a piecewise function. Okay, so how do you sketch a piecewise function? A lot of people have a hard time with this. The key here is this right there. You should not go past this right there. This is the key. So all I'm going to do is graph this line, and then I'm kind of erase what I don't need. So I'm going to do some purple. 2x plus 3. We're going to start at 3. Our slope is 2, so I'm going to go up 2 over 1. That's going to be my graph's inside effect. But here's the rub. I only want where this is less than 1 at. Right? So where x is 1. Here's x is 1 right there. That point right there. So I don't want the rest of this. I only want the part that's less than. So less than means like to the left, right? Less than. So all these values. So I'm actually gonna erase some of these. Let me draw it again like as a dotted line. Right? Since I want less than, I always think of this, that spells less. That means to the left side. So all the numbers less than 1. So these are all the numbers less than 1. And then we're going to graph the other one. We're going to start at 4. My slope is negative 1 over 1. It's my slope from right there. So I'll go down 1 over 1. My graph's going to look like this. But in this case, I only want the ones that are greater than 1. So from 1 on. So this part I want to keep. I want to erase the rest. So let me erase the rest. And there's one more thing I got to fix. If you notice, it's an open circle. There's no line. So I got to draw an open circle here. Again, I'll do a dotted line. You don't have to do this part just to show you what the graph would look like. So that's what the graph would look like here. Look at there. Right, but only the solid parts are my answer. So I want this graph anywhere it's less than 1. So I draw the whole line. I erase the stuff that I don't need. Same thing with this one. I graph that whole line. I erase the stuff I don't need. I just need greater than 1. That's a piecewise function. Okay, last bit of stuff here. Even and odd functions. An even function folds like a book. Fold in half. Like a book. Technically, we say you could fold it across y-axis. Right, so if you cut it in half across the y-axis here, like cut it in half, that's an even function. So if you're symmetric across the y-axis, this is even. An odd function is a little funky. It's symmetric across the origin, so like it repeats itself like here. So this is an odd function. See how it does like this thing? So that's considered an odd function. And then if it's symmetric across the x, it's not a function. But those are the only two we have. We have even and odd. If it's not one of those two, it's neither. So let's look at our examples here. So this first one here, looks like it folded in half like a book. This is an even function. The next one, notice how this guy matches this guy. That's an odd function. This one, you like, I could fold it across right here. That doesn't count. It has to be right down the middle. It has to be the y-axis. So this is neither. So none. And then this one, that does fold in half. So this would be even. So that's the idea. One final part of this. How do you tell if it's an even or odd function based on like mathematics? So here's the key right there. If it's an even function, all we're going to do to tell this, let's recap first. All we're going to do is we're going to sub in f of negative x, right? It's different. So instead of everywhere where you see an x, you're going to plug a negative x in. And then what happens? If that doesn't change a thing, if it all goes away, it looks exactly the same. You know, you plug a negative x, that's considered an even function. If all the signs change, if all of them change, like they're all different signs, that's considered odd functions. If you get a mix, it's neither. Right, so if it stays exactly the same, even. If everything changes, signs, odd. If it's some mixture, neither. So we're going to do this real quick. So A, we're going to plug in g of negative x. So right, wherever there's an x, we're going to plug in a negative x. So like here and here, I'm plugging in a negative x. And then let's see what happens. Negative x cubed stays negative x cubed, right? Odd power keeps the negative. Negative times a negative is a positive x. If you look at that, all the signs switched. This is an odd function. If you want to be like more mathematically correct about it, you can factor out a negative from all this, and you get this. Right? You get the negative version of what you started off with. Again, I always stop here and I say, oh, all the signs changed. Odd. But if you want to be like more correct, you could factor out the negative and be like, oh, it's a negative version of what I got. So that's that one. Let's look at B. We want h of negative x, and h of x is x squared plus 1. We're going to plug in negative 1, negative x, sorry. When you square a negative, it becomes positive. And that's the only thing that happened. If you notice, nothing changed. That's the exact same thing we started off with. That's an even function. Alright, so if nothing changes at all, even. And then the last one here, we're going to do c. So f of negative x. We're going to get that minus 1. Let's plug in a negative x. Odd power keeps the sign. So negative x cubed, negative 1. If you look at this, it's a mixture. The x changed from that to negative, but the negative 1 stayed the same. So this is none. It's not even or odd. So if it all stays the same, nothing changed, even. If they all change signs, odd. If it's some mixture, none. And that's the lesson.